NEC 110.14 requires that the ampacity of a conductor be sufficient for the maximum load it will carry. In the given scenario, number 8 American wire gauge conductors are connected to the same lugs as the conductors feeding a subpanel from a 200 amp breaker. The number 8 American wire gauge conductors are feeding an air conditioning disconnect located 8 feet away. The problem is that the number 8 American wire gauge conductors have an ampacity of only 40 amps, based on the 75°C column of NEC table 310.16. The 200 amp breaker, however, is designed to allow up to 200 amps to flow through it before tripping. This means that if a fault or overload condition occurs that draws more than 40 amps but less than 200 amps, the number 8 American wire gauge conductors will be subjected to a current exceeding their ampacity. This can cause the conductors to overheat, potentially leading to insulation damage, fire, or other hazards. The NEC aims to prevent such situations by ensuring that conductors are always protected by an overcurrent device, such as a circuit breaker or fuse, that is properly sized to their ampacity. In this case, the 200 amp breaker is not providing adequate overcurrent protection for the number 8 American wire gauge conductors. To correct this violation, there are a couple of options. Firstly, the number 8 American wire gauge conductors could be replaced with conductors that have an ampacity of at least 200 amps. However, this is likely impractical and unnecessary, as the air conditioning disconnect probably does not require that much current. Secondly, a smaller overcurrent device, such as a 40 amp breaker or fuse, could be installed in series with the number 8 American wire gauge conductors before the air conditioning disconnect. This would ensure that the conductors are protected from overcurrents exceeding their ampacity. It is crucial to understand how to apply NEC 110.14 correctly. This section isn't just about picking wires that can handle the load you expect. It's about making sure the overcurrent protection device, like a breaker, matches the wire's ability to handle current safely. The NEC has tables, like 310.16, that tell you the maximum current a wire can handle based on its size and temperature rating. You must always use the right table for the type of wire you're using. Also, think about the temperature where the wires are located. If it's a hot environment, the wire's ampacity goes down and you need to adjust accordingly. The goal of NEC 110.14 is simple safety. Overloaded wires get hot, which can melt insulation and start fires. By following the code and matching your wire size to the breaker size, you prevent this from happening. When you're working on electrical systems, always double-check your wire sizes and breaker ratings. It's better to be safe and correct than sorry later. If you're not sure, it's always best to ask a qualified electrician for help. They can make sure your installation meets code and is safe for everyone. The NEC isn't just a set of rules, it's a guide to making electrical systems safe and reliable. By understanding and following it, you can protect yourself, your property, and others from electrical hazards. Therefore, in the scenario presented, NEC 110.14 is violated because the number 8 American wire gauge conductors are not adequately protected by the 200 amp breaker. A smaller overcurrent device must be installed to protect the conductors from overcurrents exceeding their ampacity, or the conductors need to be upgraded to handle at least 200 amps.